now let us start Ohm's law in vector form. Okay, for this consider one conductor like this, and this conductor is connected with a battery or cell, I can say. Okay, the potential difference across this battery is V, and let us say L is length of the conductor and area of cross section of the conductor is A. Okay, so this is a conductor and this conductor is having free electrons. Okay, so the potential difference is connected across this conductor, therefore a potential difference is set up here and electric field is set up here. Okay, and this electric field, due to this electric field, the free electrons inside the conductor, they drift. Okay, and those free electrons constitute electric current. Okay, so let us say I be the electric current, okay, that is flowing through this circuit. Say I is electric current. Let I be the electric current flowing in or flowing through conductor. Flowing through conductor. Okay. Then from Ohm's law, as we know, Ohm's law is the potential difference across the ends of the conductor is directly proportional to the electric current in the circuit, right? Therefore, I can write V is equal to IR, where I is electric current and R is resistance of the conductor, and V is potential difference. Okay, so let us call it as equation 1. But as we know, resistance of the conductor is depending on certain factors, that is, resistance is directly proportional to length of the conductor and it is inversely proportional to area of cross section of the conductor. Okay, and instead of proportionality symbol I can write a constant, and that constant is called as what? Resistivity. Okay, rho. Let us call it as equation number 2. Putting 2 in 1. Okay, therefore V is equal to I, in place of R I can write rho L divided by A. Let us call it as equation 3. As we know the relation between potential difference and electric field, because we have connected electric potential difference, we have connected battery here, and this battery creates a electric field across the ends of the conductor, right? And that I can write relation between E and V, where E is electric field and V is electric potential, and that I can write E is equal to dV divided by dr, where dV is what? Electric potential and dr is what? Distance. And in this case I can write it as E is equal to V divided by L, because L is length. Okay, an electron is traveling from this point to this point. That is what we have assumed. Let us call it as equation 4. Okay, this equation 4 is substituted in equation 3, or I can write it as V is equal to E into L. Let us say this is equation 3. V is equal to E into L. Now equation 4 is substituted in equation 3. Putting 4 in 3. Therefore, in place of V I can write E into L is equal to I rho L divided by A. L is cancelled on both the sides. Therefore, E is equal to I rho divided by A. Here I is electric current and A is what? Area of cross section of the conductor. And as we know, electric current per unit area is called as what? Current density. Therefore, I can write it as E is equal to I by A is called as what? J. What is J? J is current density and rho. Okay, I will write here where J is equal to I divided by A. Okay, and remember this rho is what? Rho is resistivity. Resistivity is property of material. From material to material, this resistivity value changes. For example, copper is having a fixed resistivity, aluminum is having a fixed resistivity. Okay, it is not depending on resistivity, is not depending on configuration of a material, but it is depending on material itself. Okay, from material to material, resistivity changes. And reciprocal of resistivity called as what? Conductivity. Resistivity is equal to 1 divided by sigma, where sigma is what? Conductivity, and rho is what? Resistivity. Okay, so in place of rho, I can write 1 divided by sigma, or J is equal to sigma E, where J is current density, which is a vector quantity, and E is electric field, which is a vector quantity. So this is vector form of Ohm's law. Okay, remember, a very important and much asked question. Vector form of Ohm's law. And sometimes this is also called, this equation is also called as equivalent form of Ohm's law. Okay, equivalent form of Ohm's law, that is J is equal to sigma into E. Okay, so please note, my dear students, a very important equation, J is equal to sigma into E. So this is all about vector form of Ohm's law. Now we shall discuss drift velocity. To understand drift velocity in an easy way, okay, please have a look. Consider one conductor. Okay, conductor is having many free electrons. Okay, and these free electrons inside the conductor are responsible for electric current in solid conductors, I mean solid metals. Okay, and this conductor is connected to a battery which is having a potential difference of V. Okay, and due to this battery, an electric field is set up across the ends of this conductor. Okay, what happens? The electrons, free electrons inside the conductor, okay, they are in motion. Okay, they are getting energy from the outside, thermal energy they are getting, and due to that thermal energy, all the free electrons inside the conductor are moving in random direction. Okay, in all the direction inside, within the conductor. Okay, they cannot come outside. Okay, because when they come outside, they experience huge amount of, very large amount of force, Coulomb force. Due to that Coulomb force, they tend to move inside the conductor only. They always remain inside the conductor only. Okay, but they are in motion, random motion. Okay, and the moment electric field is set up here, all the free electrons inside the conductor, they start moving. Okay, in the opposite direction of electric field. The direction of electric field is from positive to negative. This is the direction of electric field. This is the direction of electric field, and all the electrons, free electrons inside the conductor, they are moving in this direction. Free electrons, they are moving in this direction. Okay, and the direction of electric current, conventionally it is considered as the direction of the flow of positive charge, I mean the direction of electric field. Electric field is in this direction, therefore electric current is also in this direction conventionally. Okay, and the velocity with which these free electrons inside the conductor are drifting in a direction opposite to the electric field is called as what? Drift velocity. Very simple definition. The free electrons inside the conductors moving or drifting with a velocity in opposite, in a direction opposite to the direction of electric field. Electric field is called drift velocity. Drift velocity. This is the definition of drift velocity. Okay, see, the free electrons inside the conductor are experiencing a force due to electric field, and that force due to electric field is given by force due to electric field is given by, as we know, it is F is equal to Q into E, where Q is charge and E is electric field. Instead of Q, I will take it as E. Okay, and here I will place a negative sign here because the force and electric field both are in opposite direction. Okay, and these electrons, free electrons, they are drifting with acceleration, and that acceleration is given by acceleration of electrons is acceleration A is equal to F divided by m, where m is what? Mass of electron. Mass of electron, because electrons are drifting, therefore I have considered electron. And A is equal to, in place of F I can write minus E divided by m. This is the acceleration of free electrons. Okay, and the average velocity, because many electrons are there, therefore the average velocity is average velocity of free electrons. Free electrons we can find out with the help of equation of motion, that is V is equal to U plus AT. Okay, because V is final velocity, U is initial velocity. This V I can consider it as Vd. What is Vd? Vd is drift velocity. Vd is drift velocity, and initial velocity of electrons is 0, and acceleration is minus E divided by m, and T is there. T is what? Time. Okay, all the electrons, they are moving with certain velocity, and that velocity is Vd. Okay, and time we can consider it as tau, average time of all the free electrons. Okay, where this is called this is called as what? Tau, and tau is what? Relaxation time. Tau is relaxation time. Okay, relaxation time, understand the meaning, my dear students. Okay, this is conductor, and this conductor is having free electrons like this. Okay, this free electron, it will collide with this. Okay, and the time taken by this electron, okay, to collide with this electron is called as what? Relaxation time. Okay, and there are many free electrons, they collide each other. Okay, because they are moving randomly and they collide each other, therefore the average time taken by the electrons to collide each other is called as what? Relaxation time. Okay, and instead of T I can write it as tau, where tau is relaxation time. Relaxation time is time taken by the electrons to collide, okay, from this place to this place, or from this place to this place. The time of collision is in many case it is small, in many case it is large. Okay, because many electrons are there, they collide each other. Okay, therefore if we consider average time, and that average time is treated as what? Relaxation time. Okay, okay, let us now discuss the relation between electric current and drift velocity. Okay, so please look here. For this, once again consider a conductor. Okay, and this conductor is having a length of L and area of cross section A, and this conductor is connected across a source, a battery, having a potential difference of V. Okay, and due to this potential difference, I current is flowing, and electric field is set up across the ends of this conductor, that is positive, negative. Say this is the direction of electric field, and many free electrons are there inside the conductor, and those free electrons inside the conductor, they are drifting, okay, in a direction opposite to the direction of electric field. It means this is the direction of drift velocity. Okay, so let us start our derivation. Let L be the length of conductor and A is area of cross section of the conductor. Okay, therefore volume of the conductor is volume of conductor. I can write it as A into L, where A is area and L is length. Okay, and area multiplied by length is called as what? Volume. Okay, volume is equal to length into breadth into height. Length into breadth, I can take it as length into breadth is taken as area, and one more length multiplied with this is considered as volume of the conductor. Okay, and let N be the electron density, and electron density I can write it as N is equal to capital N divided by A, where capital N divided by V, where N is what? Total number of electrons, and V is what? Total volume. Number of electrons per unit volume is called as what? Number density, or total number of electrons is equal to number density into volume. That way also I can write. Okay, and N divided by V is what? A into L, or N is equal to total number of electrons is equal to N A L, where N is number of electron density, and A is area, and L is length. Okay, and total charge of electrons is equal to, it is E is charge of one electron, but there are NaL electrons are there, therefore NaL multiplied with charge, that is NaL. Okay, remember E is charge of one electron, but in a conductor NaL charges are there, electrons are there, therefore total number of electrons having total charge, how much? E multiplied with NaL, right? Okay, next let T be the time taken by the electrons to cross the length L. Consider the electrons are crossing from this point to this point, having a length of L, and that I can write time is equal to velocity divided by distance. Distance is L. Sorry. Distance is equal to velocity is equal to distance divided by time. Distance is how much? It is L, and time is how much? It is T, and Vd is what? Drift velocity. They are moving with drift velocity. Therefore T is equal to, I can write L divided by Vd. Okay, so let us call it is equation 1 and it has equation 2. And next, the electric current across the conductor. As we know, the electric current formula I is equal to Q divided by T. Therefore, I can write I is equal to Q divided by T. But in place of Q, I can write it as Q divided by T. Okay. So, as we know from this, we know T, okay, and we know Q also. Q is equal to ENAL is there. Therefore, I is equal to, I can write, in place of Q, I can write ENAL, and T, in place of T, I can write L divided by VD. L is cancelled on both the side. Therefore, I is equal to NEAVD. So this is the formula for relation between electric current and drift velocity. Okay. Here LL is cancelled and VD it goes on numerator. Therefore, I is equal to NEA VD, where N is number of free electrons per unit volume or number density, electron density, and E is charge of electron, and A is area of cross section of the conductor, and VD is drift velocity. Here NEA are constant, where VD is variable. Therefore, I is directly proportional to VD. I is directly proportional to VD. But remember, my dear students, this VD is, drift velocity is very small, because in this conductor there are n number of electrons are there, many number of electrons are there. Okay, and those many number of electrons, they drift with very small velocity. Therefore, this VD is very small. Even though VD is very small, that constitute very sufficient amount of electric current. Okay, because the number of electrons are huge number. Okay, so note this derivation, very important derivation. And in place of VD I can write see, VD is there, drift velocity, and I is equal to NEA. VD I can write it as E tau divided by M. This is formula for drift velocity. Therefore, I is equal to NEE, it is E square, A E tau divided by M. This is also one formula for the relation between electric current and electric field. Okay. So next, one definition is there, and that is electron mobility. Electron mobility. Electron mobility, it is indicated by mu. Okay, and mu is equal to VD divided by E, where VD is what? Drift velocity, and E is what? Electric field. Ratio of drift velocity to the electric field is called as what? Electron mobility. Okay. A ratio of drift velocity to the electric field is called mobility or electron mobility. Electron mobility. Mobility means move. Okay, electron moment. And see some points on electron mobility. Mu is equal to VD divided by E is there. Okay, therefore its unit the unit of VD velocity is meter per second, and electric field is there. Electric field is having two units actually. One is Newton per coulomb, another one is volt per meter. Okay, I will write volt per meter. Volt per meter, or I can write it as meter square per second per volt. Right, this is one unit, and another unit meter per second, and electric field is there. F is equal to QE, and E is equal to F divided by Q, where F is Newton, Q is coulomb. So Newton per coulomb. Therefore, I can write it as meter coulomb per second per Newton.